Jimmy Liu, Didier Chu, Jackman, and my supervisor, Dr. Xiao Hu. So the title of this paper is Leveraging LMS logs to analyze self-regulated learning behaviors in a maker-based course. This study is a follow-up study related to a previous paper published in Black 2022, so you can scan the code and read the paper. Okay, so let's start with the introduction. So forgive me if I read, this is how I will introduce the work to you. So this study is about self-regulated learning, which is well known in the field and is often regarded as a theoretical foundation of learning analytics. In our previous study, we reported that students' need for self-regulated learning, it's very well needed for the support of the students. However, SRL is an active, constructive, and recursive, so it is very challenging for them to understand and for us to understand the behaviors the students go through. Also, learning management systems, or LMS, such as Moodle, Blackboard, or Canvas, can provide a means to infer the behaviors of students or self-related behaviors during the authentic context of learning. Okay. So in this sense, students' self-regulated learning behaviors are operationalized as frequencies and sequences of actions that a student perform in this LMS. So these behaviors can reveal patterns in that are context specific and may vary across students with different learning performances. Oh, I think she's here. Yeah.
Okay, can she?
Oh, hello. Is the audio working now?
I think we cannot hear her. She might be trying.
I'm trying. I'm saying something, but it seems like the online audience can hear me, but the on-site audience cannot hear me. Yeah.
Oh, you're not gonna hear it because you're on the laptop because the audio is being rerouted. Oh, yeah. Switch to classroom PC. Okay, can she talk now?
Yeah.
Okay.
Okay. Sorry, there's the echoes. Okay, so is it better now?
Yeah.
Yeah.
Right here. Oh, I see. We're not using this mic.
All right.
Okay.
Is it all right? Can I continue? Okay. Thank you. Thanks everyone, and especially the online audience and the on-site audience. I know this is very challenging. Okay, so I will continue from this point on. Basically, this study is related to self-regulated learning, and it's difficult and challenging to understand students' self-regulated learning behaviors. However, we have we have learning management systems such as Moodle, which can help us provide system logs that can help us infer learners' self-regulated behavior by capturing the learner and system interactions during the context of learning. So in this sense, the students' self-regulated learning behaviors can be optionalized as frequencies and sequences of actions that's logged in the system. So that's why this study focuses on the system logs. So there have been learning analytics studies on self-regulated learning research, but there are very few studies in the maker education context. Okay. Maker education is a student-centered pedagogy. It is grounded in constructionism and characterized by students' autonomies and flexibility. Students acquire knowledge and skills through creating real-world artifacts. Existing studies on maker education mostly focus on learning outcomes and products rather than the learning process across time. There are even fewer studies using learning analytics to examine the process of maker activities. Therefore, this study is a starting point focusing on the macro level of self-regulated learning patterns. By macro level, we refer to student behaviors across the weeks of a maker activity, rather than the micro level, which can be hour by hour or minute by minute patterns. The present study focuses on two research questions, both on comparing between high and low performing students, but one question focuses on frequencies of self-regulated behavior, and the other focuses on sequential patterns of self-regulated behavior. The findings will contribute to integrating the learning analytics-based SRL analysis into maker education. In terms of methodology, this study demonstrated that the learning management system logs, which are readily available to most teachers, can be used to study learning process of maker activity. This provides an alternative solution to the practical challenge that most platforms for maker activities do not provide access to trace data logged in the systems. Practically, the findings would provide suggestions to teachers improving the pedagogy or the LMS designs and student self-regulated learning, as well as implications for visualizing the self-regulated learning patterns in student-facing dashboards. Now let's proceed to the research context and methods. This study was conducted in the undergraduate general education course on digitizing cultural heritage. The learning outcomes include understanding values of cultural heritage and creating digital artifacts for cultural heritage. The course consists of online lectures on content knowledge and face-to-face tutorials on hands-on maker activities. Both paths use the Moodle, the learning management systems. Students in this course needed to produce multiple digital artifacts, including a poster, a virtual reality story, and a digital gallery. The design of the learning activities and Moodle support were based on the recommendations in the literature on implementing maker activities in the classroom. For example, for scaffolding learners' planning and preparation, and during the maker, so the instructor teams actually uploaded the course outlines with assessment requirements and rubrics to Moodle so that the students can refer to those materials from time to time. To empower students' participation in the community of practice and to generate collective innovations during the maker activities, the Moodle forums were set up for students to share their thoughts and to submit draft artifacts for peer review. For prompting the students' reflections, the Moodle's built-in questionnaire activities was used to collect students' self-reflections. Last but not least, students also submit deliverables of their assignments in Moodle using the assignment activities. There were a total of 104 students participating in this study. Over half of them were female or from non-STEM fields. We collected their learning logs on Moodle, performance scores, and their reflections. In total, there were over 63,000 log events, from which 48,000 were recognized as SRL events. The rest of them were course homepage views and other not really meaningful actions. The performance scores were used to divide the students into high and low performing groups based on the median so that the two performance groups had the same sample size. For the system logs, we used the non-parametric test and sequential pattern mining. For reflections, we used the semantic content analysis with intercoder reliability checked. With reference to current learning analytics-based SRL research, we defined the students' SRL behaviors according to the context of maker activities and optionized them as various Moodle log-based events. So here its table shows the mapping between the SRL phases and behaviors and also the events logged in Moodle. There are three phases according to the SRL literature: learning, planning, engagement, and evaluation and reflection. Take the second phase as an example, engagement. It covers both the working on the task and the reformulation, which is the modification on the artifacts in this context. These two behaviors are mapped to the different events in the Moodle, including submission, the drafts, and modification of the artifacts. Okay. Proceed. Okay, now let's see the results. For the first research question, the results from Van Whitney U-test revealed that the high-performing students were more frequent in performing 5 SRL behaviors, including making personal plans, working on a task, reformulation, evaluation, and reflections. Okay. And the quantitative data from the students' reflections also echo the patterns that high-performing students mentioned more SRL behaviors in their reflections in almost all the behavioral categories. For research question 2, the two student groups shared a similar frequent sequence of behaviors. For most of the patterns, the high-performing group had higher support values. So support values is the frequency. The most popular pattern is the reflection followed by reformulation. Okay, but for this pattern circled in green, the working on the task after reformulation. So this one is unique to the high-performing group. So that indicating that the high-performing group actually did the reformulation and working on a task back and forth more than the low-performing groups. The qualitative data analysis supplements the results. Both groups of students mentioned frequent SRL sequences in their reflections, while those in the high-performing groups had higher frequencies, except for this pattern. So this one, actually, the lower performing group has higher frequencies. So this is reformulation after evaluation. But the high-performing group were more often to mention that they continued reformulating after the reflection, meaning that they continue improving their artifacts. Here are some discussions based on the results. Results of first research question confirm that the students of low and high performing groups actually demonstrated different patterns of SRL. So this was found before in other scenarios of learning, but here we confirm this pattern in maker-based course. And high performing learners had more SRL behaviors. The result of the second research question revealed that most frequent sequence in both groups was this reformulation after reflection. The Qualitative analysis found that the high-performing students often reflected on the product content, while the low-performing students tend to reflect on technical issues. This implies that teachers can provide some more guidance in reflection, so to encourage more reflection on the product content. High-performing group actually have higher frequency and on the pattern that is goal setting after reformulation, which means that the students reviewed the course materials, including the task requirement, before making edits to their artifacts. So a suggestion based on this is that teachers could remind the students of the objectives and requirements of the maker activities. Last but not least, reflections as SRL behavior appeared in nearly all the patterns we found, and it was occurred both after and before other self-regulated learning behaviors. So this finding denotes that the essence of reflection as a formative metacognitive activity in maker education for students to gain both retrospect and projective insight into their own making and learning process. So the implication is that reflection should be built into maker education. So here are the conclusions. Overall, this study contributed to integrating learning analytics-based SRL analysis into maker education, and particularly the use of learning analytics to offer quantitative learns for examining maker activities, and also the use of learning management system logs that are accessible to educators and researchers. Pedagogically, we demonstrated that instructors can encourage sustainable SRL behaviors through several means. First, to maintain careful alignment between maker-based pedagogy design and the learning management system activity design. Second, to create and foster a community of practice through peer support. And the last, not least, to prompt guided reflections among students. Our ongoing work includes implementing this pedagogical improvement suggested in this study and continue examining the effects on learners' self-regulated learning during their maker activities. Okay, so here are QR code of our research group and our publications, and we look forward to discuss with everyone. Even if after this session, you can still leave questions in Wova, and I will be answering the questions. Thank you.